So chapter 10 is going to be talking about states of matter, liquid and solid. Now it's going to be really important that you can tell the difference between an intramolecular force and an intermolecular force, okay? So an intramolecular force is when you have atoms that form molecules by sharing electrons. So this is called intramolecular bonding. So think of a water molecule forming. An intramolecular force would be the covalent bond between the hydrogen and the oxygen atoms in your water molecule. An intermolecular force occurs between two different molecules. So an intermolecular force, we've already built our water molecules, but we're going to have these forces connecting different water molecules to each other. Now, this is not true bonding, and it's weaker than bonding. It's weaker than the intramolecular forces, okay? So whenever we have a change in state, melting, boiling, freezing, we're changing our intermolecular forces. When I boil water, I have liquid water becoming water vapor. It's still water, so I didn't break any of the bonds between the hydrogen and the oxygen atoms. I still have water, but I'm taking different water molecules and breaking intermolecular forces. Now we've got some different types of intermolecular forces, and it depends on the type of molecule that we have for what type of intermolecular forces we'll have. So a dipole-dipole force, we have to have polar bonds. Remember, we get polar bonds when we have differences in electronegativity. So when we have these polar bonds, we're going to have a positive end and a negative end, which creates dipole moments. Somebody has more electrons, somebody has less, so we're going to have a partially positive side, a partially negative side. Okay? So what's going to happen is all of my molecules are going to line up so that opposite charges find each other. A positive end of one molecule is going to want to be by the negative end of another molecule. Now again, it's nowhere near as strong as an actual bond. It's only about 1% as strong as an ionic or covalent bond, and the further they are away from each other, the weaker they are. So as my molecules get further and further away, the dipole-dipole forces get weaker and weaker. Now, the second type of intermolecular force is a hydrogen bond. Even though we call this a bond, it's not a true bond. It's a type of dipole-dipole interaction. Now, because it's a hydrogen bond, we have to have hydrogen. And then we have to have something that's very electronegative. Now, when we say electronegative, there are only 3 atoms that fit this bill: fluorine, oxygen, and nitrogen. Hydrogen bonding is fun, okay? Now, hydrogen bonding, because there's such a big difference in electronegativity, it's going to be stronger than true dipole-dipole forces, but we're going to have both types of forces in a molecule with H and F or H and O. It's going to have hydrogen bonds and dipole-dipole forces, okay? Now, London dispersion forces, we'll also call these LDF. London dispersion forces, what's going to happen is these are going to apply to all molecules. While dipole-dipole is only polar, London dispersion can be polar or nonpolar, okay? So what's going to happen is the electrons are moving around the nucleus. Now, occasionally we're going to have more electrons on one side than the other, and so we're going to have a temporary dipole. So if I wind up with more electrons on this side, it's going to be partially negative. The side that has less will be partially positive, so I have this temporary positive and negative side, temporary dipole. Now, when one molecule becomes partially positive and partially negative, the one next to it will try to do the same thing so that it can line up. So it creates a chain reaction. These are the weakest of the three types of intermolecular forces, okay? Dipole, dipole, hydrogen, and LDF. But as the molecule gets bigger, there are more electrons. And because there are more electrons, the LDF gets stronger, okay? Now, remember, London dispersion forces can be polar or nonpolar. So a molecule that is nonpolar will only have LDF. A molecule that is polar will have LDF and dipole-dipole. A molecule that is polar and contains hydrogen and fluorine or oxygen and nitrogen will have LDF, dipole-dipole, and hydrogen bonds. So we can have more than one. So, for example, if I was looking at CH4, CH4 looks like this. It's going to be a non-polar molecule. Because it's a non-polar molecule, the only type of intermolecular force it can have is LDF. Take a second and figure out what B and C can do. Example 2 wants you to figure out which molecule will exhibit the strongest London dispersion force. Remember, these are all nonpolar molecules. They all have London dispersion, but think about this hint. It gets stronger as the molecule gets bigger. So which one of these three would have the biggest London dispersion force? Okay? So just a quick summary. Remember, intramolecular forces are bonding. Intermolecular forces are attractions between molecules. They're very different things, and you need to know the difference between the two.